This is question number 8 from the MyLab Math homework number 18, covering section 3.2. And in this problem, we're told that the number of virus cells increases by 38% each day. And we're being asked, what is the common ratio? So that word common ratio is a clue that we're going to have exponential growth. Another clue is that it's increasing by a percentage each day. So we're increasing by 38% each day. So we're not increasing by a certain number of bacteria. That would be linear. So a little side example over here. If we were told that we were increasing by 38 bacteria per day, that would be linear. This is what that would look like. Let's say on day 0, we had 100 bacteria. So my input are number of days. My output is number of bacteria. So let's say on day 0, we had 100 bacteria. If we were increasing by 38 bacteria per day, I would just take 100, add 38 bacteria to it, and the next day, one day later, I'd have 138 bacteria. And then to calculate the next day, I would just take 138 and I would add 38 more bacteria on there, right? So that'd be 176 bacteria and so on. So if the pattern was repeatedly adding a certain number of bacteria every day, that would be a linear pattern. But we're not told a certain number of bacteria each day. We're told it's increasing by a percentage. So what would that look like? Let's use the same example here where my number of days is my input. And I'm calculating number of bacteria. And let's still start with that 100 bacteria. And I'm just making this up as an example. If I'm going to increase by 38% each day, that means on the very next day, I'm going to have that original 100 bacteria plus extra. So this original 100 bacteria, that's like your 100%. So if I'm going to take that 100 bacteria plus 38% more, then the next day, I'm going to have 138% of what I had before. So I'm going to have the original 100% plus extra. So I'm going to have 138% total. So I'm going to take that 100 bacteria and I'm going to multiply it by 138%. So I'm going to take that 100 bacteria and I'm going to multiply it by the decimal form of that. So multiplying by a number bigger than 1 means my amount's increasing. So that 1 is representing the original whole, that original 100%, and then the 0.38 is representing that extra percentage. So when I multiply that, I would end up with, 138 bacteria the next day. Okay, so then I'm going to take that amount, so I'm going to take that 138%, and I'm going to 138 bacteria, and I'm going to increase that by 138%. Okay, so I'm going to take 138 bacteria and multiply that by 1.38. So let me do that on my calculator and see what we get here. So 138 bacteria, 138% of that. Then I have 190, approximately 190.44, but I can't have 0.44 of a bacteria, right? So I can see now that's different than my linear amount on day 2. My linear amount on day 2 would be 176 bacteria, but my exponential amount on day 2 is 190 bacteria. So that common ratio is the number we're repeatedly multiplying by. So if I'm increasing by 38%, I have that original 100% going on, the new amount is 138% of the old amount. So my common ratio, the number I actually multiply by, is going to be 1.38. I need to multiply by a number greater than 1 to create larger and larger outputs every day.